Hi, I'm Ms. Cho, and in this video we'll solve rational equations using cross multiplication. We've talked before about how rational expressions are like fractions except with one polynomial divided by another instead of numbers dividing by one another. Fractions that are equivalent share a property where their cross products are equivalent. So 1 times 10 is 10 and 2 times 5 is 10. So because their cross products are equal, I know that 1/2 is equal to 5/10. I can use the same property to solve equations involving variables. So for example, if I have x plus 3 is equal to 4/9, I know that my cross products are going to be equal. So 9 times x is going to be 3 times 4. And that means 9x is equal to 12. If I divide each side by 9, I get x is equal to 12/9, which I can divide by the greatest common factor of 3 to get 4/3. Let's take a look at an example. Here we're asked to find the solutions of the equation 4 over 5x minus 3 is equal to 2 over 3x plus 4. To do that, I'm going to follow 5 steps. First, I find the domain. Second, I ask if each side only has one fraction. Third, I cross multiply and set the cross products equal to each other. Fourth, I solve the equation, and then 5, I have to check my solutions to see if they are in my domain. If they are undefined, I have to throw them out, and these are called extraneous solutions. First, I'm going to find my domain. My domain is all x's except what makes my denominators equal to 0. So 5x minus 3 equals 0 gives me x is equal to 3 over 5. And if I have 3x plus 4 equals 0 and I solve it for x, I get x is equal to negative 4/3. So that means these two are invalid options, but I can use everything else. Second, I'm going to ask, does each side only have one fraction? My left side is one fraction and my right side is one fraction, so that's a yes. If it's a yes, I can cross multiply. So that means 4 times the 3x plus 4 is going to be equal to 2 times the 5x minus 3. From then, I can simplify using the distributive property and get 12x plus 16 is equal to 10x minus 6. I subtract the 10x from both sides, I get 2x on the left. If I subtract the 16 from both sides, I get negative 22 on the right. Dividing by 2 gives me x is equal to negative 11. Once I've solved it, I can check to see if it's in my domain. X equals negative 11 is not one of the undefined values, so I can keep it. How do I know if I'm right? I can do this two ways. I'm going to check algebraically by plugging in the negative 11 back into my original equation, or I can use a graph. I'm going to pause the video and do the algebraic check now. In this last step of my algebraic check, I want to know if these two fractions are equivalent. I notice that I can multiply 2 by 2 to get 4. So if I multiply both the numerator and the denominator by 2, I get negative 4 over 58, which is the same as the left side, so that checks out. To check on the graph, I'm going to graph the left side as one function and the right side as one function and look for their points of intersection. My left side is in red and my right side is in blue, and I don't see any points of intersection right now, so I'm just going to zoom out and click on the graph. And I see that there's a point of intersection at x equals negative 11, which is what we found algebraically. So this is a confirmation that we did it correctly. Let's try a second example. Here we are asked to find the solutions of the equation 2 over x minus 3x over x plus 3 is equal to x over x plus 3. First, I'm going to find my domain, which is all x's except what makes my denominator 0. So x equals 0, and then x plus 3 equals 0 gives me x equals negative 3. So these are my undefined values that I cannot use, that I have to keep an eye out for. Next, I ask, does each side only have one fraction? No, I have two fractions on the left and one fraction on the right. So my options are, I can combine to make one fraction, or I can multiply through by the least common denominator, which is another video. So I'm going to combine them because I noticed that two of them have the same denominator, so I can add them pretty easily. So I'm going to move this term to the other side by adding it. So I'm left with 2 over x is equal to x over x plus 3 plus the 3x over x plus 3. And because these are like denominators, I can just add across the top to get 4x over x plus 3. Now that I have one fraction on each side, I can cross multiply. So 2 times x plus 3 is equal to 4x times x. And that gives me 2x plus 6 is equal to 4x squared. I'm going to move my left side over to my right side so that I have a positive coefficient for my x squared. And then now I have a quadratic, which I'm going to factor out a GCF of 2. It's 2x squared minus x minus 6, minus 3, is equal to 0. And then I'm going to factor by grouping. I'm going to look for two numbers that multiply to 2 times negative 3, which is negative 6, and then add to my b term, which is negative 1. So I think that's going to be 3 and 2 with a negative in front of my 3. So that means this is going to be 2x squared plus 2x minus 3x minus 3. And if you need a refresher on factoring by grouping, you can check out my video. Once I have these groups here, I'm going to factor out the GCF of each one. So 2x leaves me an x plus 1 here, and then I'm factoring out a negative 3 and an x plus 1 here. And that gives me 2 times 2x minus 3 times x plus 1 is equal to 0. I set all my factors equal to 0, and this gives me x is equal to 3 halves and x is equal to negative 1. I've solved the equation, and now I just have to check, are any of these undefined values? Am I allowed to have x is equal to negative 1? Yes. And am I allowed to have x is equal to 3 halves? Yes, because I'm not allowed to have 0 and negative 3. So these are my solutions. Again, we can check this using a graph. Again, I have my left side in red and my right side in blue, and I notice I have 2 points of intersection, one at x is equal to negative 1 and one at x equals 1.5 or 3 halves. Let's summarize. Two fractions are equivalent when their cross products are equal. And to solve rational equations using cross multiplication, first we have to find the domain. Then we make sure there's only one fraction on each side of the equal sign. If there's not, we can combine down to 1, or we can multiply through by the LCM, which we'll do with a different video. Once you have one fraction on each side, you cross multiply and set the products equal to each other. From there, you can solve the equation and then exclude any extraneous solutions or values that make your denominator 0 or undefined.